Okay, here number one, we're going to solve the system by substitution. We have two equations. The top one, let's call equation one, and the bottom one, let's call equation two. So first off, look at these equations and look and see, do you already have x equals something or y equals something? Like, are one of the variables already solved for? And you should say yes, right? The top equation, in equation one, x is already solved for. You have x on one side, everything else on the other. X equals 4y plus 7. And so what you're going to do here is you're going to take this 4y plus 7 and you're going to plug it into the other equation, which would be equation 2. You're going to plug into the other equation 4x. You're going to plug it in right there. Okay, so equation 2, let's rewrite equation 2 down here. Equation 2, 2x minus 6y equal 12. And I'm taking what x is equal to 4y plus 7. I'm going to take that and plug it in right there for x. So 2 times x, I'm not going to write x anymore. I'm going to write what x is. And x is 4y plus 7. Notice how I'm putting it in parentheses. Okay, this is x, 4y plus 7. I don't write the x, I write what x is, and I put it in parentheses. X is equal to 4y plus 7. I continue copying the equation, minus 6y equal 12. Okay, from this point, I now have an equation with one variable, and so I can solve this equation using the 5 steps to solve equations to solve for y, right? Eliminate the parentheses by distributing the 2 to the 4y and to the 7. Then you would combine like terms, get the variable on one side, numbers on the other, solve for y. Once you have solved for y, you would take y and plug it back into this equation right here so you can get x. Okay, so remember your solution is some xy ordered pair. So you finished number one. Number two, you have two equations. The top one is equation one, and the bottom one is equation two. Look for, do you already have x equals something or y equals something? Are one of the variables in one of the equations already solved for? And you should say no, right? In the first equation, x and y are on the same side. In the second equation, x and y are on the same side. And so what you have to do is pick a variable in an equation and solve for it. Get it by itself. The easiest one to solve for is the variable that has a coefficient of positive 1. Remember, the coefficient is the number in front of the letter. And so the coefficient of 2x would be 2. The coefficient of positive y here would be 1, right? There's an invisible 1 right there. Down here in equation 2, this 5x has a coefficient of 5. This 3y term has a coefficient of 3. So the easiest one to solve for here is going to be positive y because it has a coefficient of 1. So let's copy that first equation down, put a 1 and circle it for equation 1. 2x plus y equal negative 2. If I solve for y, I would move the 2x to the other side by subtraction. So those 2x's cancel, and y equals negative 2 minus 2x. Okay, remember when solving by substitution, you do not have to put the x term first. When solving by graphing, putting the equation in slope-intercept form, yes, put the x term first and the constant second. But when solving by substitution, it doesn't matter whether you have the constant first or the x term first. So we'll just leave it as is. Y equals negative 2 minus 2x. Now I have y equals something. I can plug this into the other equation. Remember, this was equation 1, and so now the other equation is going to be equation 2. So let's copy equation 2. Let's copy equation 2 over here. I'll put a 2 and circle it for equation 2, and equation 2 is 5x plus 3y. Be sure you copy it down correctly. Equals negative 8. Okay, and I'm going to take what y is, and I'm not going to write y anymore in this equation. I'm going to write what y is, and y is negative 2 minus 2x. I'm putting it in right there for y. Okay, so I'm going to have 5x plus 3, and now I'm going to put what y is in parentheses. I'm going to put negative 2 minus 2x and close the parentheses. Okay, bring the equal sign down, bring the minus a down. Now I have an equation with one variable. That variable is x, and I can solve for that variable by following the 5 steps to solve the equations. I bring the 5x down. I have 3 times negative 2x. 3 times negative 2x is, 3 times negative 2 is negative 6. 3 times negative 2x, negative 6x. Bring the equal sign down, bring the negative 8 down. Okay, next step is to combine like terms. I have a 5x and a negative 6x. 5x and negative 6x is negative 1x. I bring the negative 6 down. I bring the equal sign down. I bring the negative 8 down. Because my variable is on the left side, I need the numbers on the other side. So I'm going to add 6 to both sides to undo the subtraction. I add 6 to both sides. Those 6's cancel. And so negative 1x equals negative 8 plus 6. That's negative 2. Fifth and final step is to solve for x by dividing by the coefficient of x, which is negative 1. I divide both sides by negative 1 because there's a negative 1 in front of x. Those negative 1s simplify, and so x equals negative 2 divided by negative 1. That is positive 2, right? X is positive 2. Now, that's not my solution. That is half of my solution because my solution consists of an xy ordered pair. So I'll put the 2 first. It's the x. Now, how am I going to get y? Do I have some equation that says y equals? Yes, I do, right here, right? This equation right here says y equals negative 2 minus 2x. So I'm going to copy it down. I'm going to plug x in right there. Okay, so y is going to be equal to negative 2 minus 2 times x, and x is 2, so I put 2 in for x. And so y is equal to negative 2. What is negative 2 times 2? That's negative 4. And negative 2 minus 4 is negative 6. So x is 2, y is negative 6. Okay, so my solution is 2, negative 6. Number 3, I have two equations here in this system. That's equation 1, that's equation 2. Do I already have x equals something or y equals something? You should say no, right? In both equations, x and y are on the same side. And so look for the coefficient of 1. Which variable has a coefficient of positive 1? Now, the equations might not always have a variable that has a coefficient of 1, but when it does, pick that variable in that equation and solve for it. And so that would be this x term in equation 1. It has a coefficient of positive 1. So let's copy that first equation down and solve for x. X plus 5y equal 4. I'm going to move the 5y term to the other side so that those 5y's cancel and x equals 4 minus 5y. Okay, I have solved for x now. I'm going to take this and I'm going to plug it into the other equation. So the other equation, which is equation 2, let's copy it down over here. It is 3x plus 15y equal negative 1. And I'm going to take 4 minus 5y and plug it in for x right here. So I'm not going to write x. I'm going to write what x is. So 3 times what x is 4 minus 5y. Close the parenthesis. Bring the plus 15y down. Bring the equal sign down. Bring the negative 1 down. Okay, let's distribute to get rid of the parentheses. 3 times 4 is 12. 3 times negative 5y is negative 15y. Bring the plus 15y down. Bring the equal sign down. Bring the negative 1 down. Okay, let's combine like terms. I'm going to combine my like terms here of negative 15y and positive 15y. And what happens when you do negative 15y plus 15y? Those cancel, right? Those are gone. That equals 0. And so what you're left here is 12 equal to negative 1. Is that true? Does 12 ever equal negative 1? No. Okay, so therefore we know that there is no solution. If you get a number equal to another number, no solution. Okay? No solution.